Oh, hi, good evening, everyone. So, welcome back to Plan 258A. So, on agenda for today, so today is Friday, it's May 3. So, there are some changes in the midterm exam answer last time. So, Aaron was able to uh, point out some of my mistake. So, and I have put the correct answer there in Moodle. Okay, so Aaron, you want to explain about your answer?
Okay, sir. Let me just share my screen, sir.
Yes, yes, please.
Sir, I cannot share a screen right now.
You can now.
Okay, then. So I think this pertains to item number 6 on the calculation of the internal rate of return. So I think initially the answer that was presented is based on our previous lesson. The answer would have been 3.63%, and it's based on an IRR of the. If you look at the Excel file, it's based on the IRR of this present value cash flows here in column K. But in actual, I think in actual practice, the discounted the IRR is calculated based on the net cash flow that is not yet discounted. So in this case, it's based on column H. Here's the benefit minus cost. So when you compute for the IRR on column H, the actual IRR result would be 8.81%, and it would make the project feasible. So again, these numbers, the benefit minus cost, it just basically the benefit for that year minus costs, and it's not in a present value form. And then you calculate the IRR based on this benefit minus cost. So yeah, sir, I think that's it.
Yeah, yeah. Thank you, Aaron. So, because it's my mistake, so for this particular problem, so you will have full grade, yeah, regardless if correct or not. So I regret it, and because of Moodle does not allow to keep the previous grade, I will still keep it in Excel. So you don't need to worry about it. Is that okay? So, if you have any comments, so well, please tell us so. So basically the lesson here, it was also enlightenment for me, okay, that the IRR should be computed based on uh, undiscounted, right? Undiscounted benefit minus cost rather than after discounting. Okay. Okay. Thank you. Next, we're supposed to discuss the assignment. Okay. So let me get it for you. Okay. Here it is. Yeah, some of you have done correctly, but some of you answer only in the first year, in the year 0. So the problem there is, so you have 10K, the principal, right? And then if you put in the bank you get 3% interest, no risk. Okay, but if you invest in a stock, so no risk mean probability is 1. If you invest in the stock, you have risk. Yeah? So there is a 7% interest on average. Okay, that is 90%. And then the stock risk is you can lose all of your money with 10%. Okay, so the question is whether you will invest in the stock or in the bank. Okay, so many of you just computed this part. Yeah. So yes, if you look at the first year, the decision is larger the bank compared to the stock. Okay. But if you put it, because this is interest, so you can put it into multi-years. Okay, and you can compute, for example, the second year is based on the first year. Okay. And the first year, again, depends on the first year, year 0 with the bank interest. Yeah. Now, in the stock, you can do the same, right? With the stock interest, okay? But this is not correct. So what you need to do is you compute it with the stock interest, okay? Multiply by the probability. Okay, multiply by the probability. And then the same thing here, you may lose everything, okay? The money previously, or multiply by the probability also, right? So with that, you can sum the two of them, okay, to get the value for the stock. So then you compare between the bank where when you put the money in the bank or you put the money in the stock. Okay? So initially, if you plot, initially, of course, the bank is greater, but after certain years, okay, so the stock will probably produce higher. So after the 6th year. I hope this is clear now. So is there any question? So even if you answer only first year, so I still give you 90. But if you want to revise, that's fine. So you can resubmit. No problem with that. Any comment, question? Okay. So for the dishonesty problem earlier, right? Right. So this is the answer of your assignment. Okay. Now, what happened if similar problem, but not just two probability, but you have many. So say this is supposed to be the more complicated assignment. Say suppose you have 100,000 and you can put in the bank the same interest 3%. Now, if you invest in the stock market, okay, you have a different probability now. Okay, a 7% interest with probably 50%, 5% interest with probability 10% and so on. Okay, you also have lose money with probability 10%. Okay, so if you calculate this, okay, so now you can see we have the stocks here. Now you put all the possible gain, right, in here. And then you also put the probability and then compute it for various years, okay, and plot it. Then you can start to see up to certain years, say up to 6 years, the stock is actually better than the bank. So if you are aiming for the long term, okay, you should probably consider the stocks. Yeah. But if you consider for the short term, the bank is actually putting the money in the bank probably better. So right, in finance, usually we measure the risk as either standard deviation or standard deviation divided by the mean. Okay, so this is called coefficient of variation, or we can also reverse. Yeah? So mean divided by standard deviation. So this is called return to risk. Okay. So up to this point, is there any question, any feedback from you? No, everything okay, right? Okay, so with that, let's make things a little more complex. Okay. Tell me first, have you ever learned about conditional probability based theorem in statistics? Yes or no? If yes, I will not review. So if no, so if you never learn about it, so I will review it. Hello, are you still there? Can you hear me? Well, have you ever learned about Bayes' theorem and conditional probability?
Sir, I think I've heard of conditional probability theory before, but I haven't fully mastered that lesson yet.
Okay, so in that case, let's review a little bit. Yeah. You can go to Google. Okay, so I have a tutorial there. Okay, so type questionnaire referral. Did you find? Oh, there. Okay. So if you just type questionnaire referral to the first one, you can enter. Okay. So this is basically what data analysis from questionnaire. Okay. So say initially you can this is very simple data analysis. So you have a research question, and these are the simple questionnaire that we make. Okay. So we have only 12 respondents like this. Okay. And then from here, you can start to analyze. Okay. So of course, before analysis, you start to put those questionnaire answer in the coding. This, okay. And from there, because these are, for example, activity in the part consists of multiple choice. So this one you need to put it out into binary, something like this. Yeah. So this is how you code, right? So, because Excel or usually the statistical software does not allow you to analyze directly in the list. So in this case, you need to put it into binary. Yeah. So let's go back to the content, and you can analyze, you can read by yourself everything there. Okay. So I will just go directly to this topic on conditional probability. So, say for example, you have cross tabulation. Okay? After you analyze using pivot table in Excel, for example, you can cross tabulate something like this. So this is the income, okay, on the columns, and then whether some respondent will actually buy new car or buy a second-hand car. Okay, so this 25 is the number of respondents who say they are from low income, and then they will buy second-hand car. Okay? And then 30 here represent the respondent, the number of count of respondent who are claiming themselves as a medium income, but they are buying second-hand car and so on. Is that clear? So the sum here, 95, okay, represent those who buy second-hand car. Okay, new here represent 155 represent the number of respondents that actually buy a new car. Okay, and 115 here represent the number of respondents that claim themselves as high income. Okay, so this is the sum of total. So when we set conditional probability, okay, we take percentage by row and by column or by total. Okay, so when we put percentage by row, this one, so 25 divided by 95, okay, you get 26%. 30% divided by 95, you get again 32% here. Okay, so when you put this number, okay, and divide by the sum on each row, this is called percentage by row. This represents conditional probability. Okay, so that is given. Okay, it is a new car, example. What is the probability that the buyer is actually from high income? Okay, that is so that one is 48. 10% here, given that they are new car. Okay. What is the probability that the buyer comes from low income? Is it clear? Okay. When you put down, okay, from here, from this down, and then you divide by the sum of each column. So 25 divided by 30, 30 divided by 5, 40 divided by 115. So you get percentage by column. Right? So percentage by column, that is exactly the same as conditional probability also. Okay, but this conditional probability represent that given that this come from a certain income, okay, what is the probability that it will buy second-hand car or yes. Maybe we did not know that it was conditional probability. Okay, so you encountered this before. Okay, so the name only, right? Okay, so the notation conditional probability is probability of the one that you want to know, so second-hand car here, and then a given. The slash here represents given that this is the condition. Okay. Now, if you put the percentage by total, okay, that represents the joint probability, the intersection. Okay, it's called joint probability. Is that okay? So because of that, we can now compute it, okay, to test whether this is, if given the table that you have, we can test, okay, whether they are independent or not. Okay. So if you have a joint probability and conditional probability, and this is called prior probability. Okay. So you can check whether the two events are independent or not by testing this value. Okay? If they are independent, okay, the conditional probability will come back to the prior. Okay, so if not, then they are dependent. So statistically speaking, like that. Now, the next one is called Bayes theorem or Bayes rule. Okay. Now, if you know the two, if you know the prior, okay, and one of the conditional probability, then you can get the other conditional probability. So that simple formula is called Bayes rule. Okay. So now the same thing as above. Okay, so if you have a percentage by row like this, right, and you know this is the percentage by row, right, and you also know the prior probability. Okay, that question is, can you get the percentage by column based on these two tables? Yes, of course. This is the one that we can compute using a Bayes theorem. Okay, so you can get back the other information presented by column, and then using that formula. So I hope this introduction is helpful. So if you have any questions, so please. Is this clear or is this not clear? If not clear, I can go to the detail. But if it is clear enough, we can go directly to our topic.
Clear, Prof.
Clear? Okay. Okay, so in that case, now based on Bayes theorem, okay, we have what is called probability from subjective opinion. Okay, so say, for example, okay, initially you have a coin. Okay, you have a coin that is initially you're thinking that this you are flipping up two coins. Okay, so initially you're thinking this is probably fair coin. Okay? But after you flip one time, okay, then you can revise your opinion based on the evidence. Then you can revise the opinion whether this coin is actually fair or biased. And if you flip many times, then the evidence will become higher and higher, so that you will know what is the actual value of the probability. So probability based on revising our opinion, it's also called Bayes theory. Okay. So let me show you in an example. Say you want to flip a coin two times, okay, to determine whether it is fair or biased. And suppose if you have n flip, will produce the head consecutively. The question is whether the probability of the coin is fair or not. So initially you don't know, because you don't know. So okay, so you said hypothesis is a fair coin. So okay, is 0.5, hypothesis that it is biased coin also 0.5, right? And then when you toss that coin, okay, oh, the result is a head. Okay, so then you can revise your opinion. Okay, say the simple way to say that it is probability of head and this is bias coin is 0.6. Okay, you can put it different numbers here as long as larger than 0.5, isn't it? Okay, and then what happens if you keep flipping that head, okay, and then you actually always get the head instead of tail in that coin, then you can start to revise your opinion based on the flipping of the coins. Okay, so first time you can get revise the opinion, okay, based on this Bayes theorem. Okay. The probability of the fair coin and then multiply by the head given the fair coins, and this is the sum of all the probability at the bottom. Okay. Then your new probability now become given that this is already had, okay, whether this is fair coin or not now becomes 0.45. Right? So 45%. Okay. And of course the other way around, so 1 minus that 1 become 54.55. So if you do that in Excel many times, okay, then eventually you will get something like this. Okay. Say when you flip n times, okay, and it's always become head, then your opinion is revised over time. Okay, that this is actually bias. This is clear. So bias rule is used to revise our opinion. Initially, you can say anything as your prior. After you get the evidence, so you revise your opinion. Okay. So the same thing earlier. So this one, you get the value. Okay. You get the percentage by row, right? And percentage by columns, then percentage by total. Okay. So then you can start to get the Bayes theorem, yeah, to check whether this is actually so given this percentage by total, okay, and percentage by row, so you can get back the percentage by column and vice versa. Okay. Now, with that, we can enter our topic with this decision tree. Okay? Can you see that? So we extend our understanding about risk analysis last time. Okay. Last time was only one table. Now you have a sequence of decision, okay, that you can use another tool called decision tree. Okay. So, and we can also discuss about risk analysis based on bias analysis, and we can compute also the value of information. Yeah. At the end, you can compute the sensitivity analysis. Okay. Okay. So when you have not just one-time decision, but you have many sequence of decision, okay, so that strategy involving a sequence of decision with the chance, okay, that is called decision strategy. So there is one tool called decision tree, which is graphical, okay, will help you to make sequential decision in decision-making process. Okay. So decision tree is very simple. Actually, you have only two types of decision. No. Okay. One is the square represent decision node, And then the other one is circle, represent the chance. Okay, so the last part on decision tree is a leaf node. So actually there are three type of node: decision node, chance node, and leaf node. Okay, so I will not put any thing in the leaf node. So now in decision node, it will branches into alternative. Now the decision in the decision node is computed by maximizing the expected value from all branches. On the other hand, on the chance node, the branches are the state of nature. Okay, so and then you compute based on the EV, expected value, which is the sum of the branch probability multiplied by the expected value. Okay, and then in the lead node, the EV is computed by the branch probability multiplied by the payoff. Okay, so let's start with example so that you can see how it works. Okay, say I have this problem. Okay, so you are owning a fruit store. Okay, whether you will order big or small. Okay, and then the state of nature is either a high demand or low demand. Okay, so this is the problem. Okay, so you want to decide about inventory of fruit store. If the demand is high and you have ordered a lot of fruit for your store, you will gain much profit, right? But if the demand is high and you only order little, okay, you lost opportunity to sell. Okay. On the other hand, if the demand is low and you order too much, your fruit become perish and you lose a lot. Okay? While the demand is low and you order on little and you gain little profit. Okay, with that, we can see, okay, in terms of table. Yeah, this is the one that decision analyst last week. Okay? So the alternative is big order or small order, right? And then the state of nature is either high demand or low demand, okay? With probability of 0.6 and 0.5, 0.4, sum is 1. And then if there's high demand and you set big order, this is your gain. Okay? If big order and there's low demand, this is your loss. Okay? And if you do small order only inventory and there is a high demand, you lose opportunity. So this is your value. If small order and low demand, this is the profit, little profit. So based on this table, you can set up the decision tree, isn't it? Okay. So in decision tree, look at this. Okay. Your first node is decision node. Okay. And then, of course, in decision node, you have alternative, big order, small order. And then this one, the yellow here represent the chance node. Okay. So the branches are the state of nature. So, and the value in the parentheses here represent the probability of each state of nature. Okay. Now the leaf node represent the payoff. Is this clear? Okay. Now, how are we going to use this decision tree, right? So we compute, okay, in 4 steps. Yeah, you want to find the optimum decision alternative from decision tree, right? So first, compute the expected value for each leaf node. Okay. And then you compute for the chance node, and then you maximize, okay, for the decision node, and then you identify the best decision. Okay, let's start with that. Yeah, so what will be the best decision alternative for this fruit store problem? These are the table, and this is the decision tree, based on this table. Right. So number one, you compute the EV for the leaf, right? So this is the decision tree. So what you will do, you multiply this one, yeah, 0.6 multiplied by 100, 0.4 multiplied by minus 100, right? So you get the EV in the leaf node. Clear? And then what you will do, because this is now the EV in the leaf node, you compute, yeah? So this is 60 and minus 40, isn't it? Okay. Then you put them together, okay, for this chance node. Yeah, you combine them together, so you get 60% times 100 plus 40% minus 100. So the value in this chance node become 20. Okay. The same thing with the small order here. Okay. So multiplying the probability with the value. Okay. So now the EV in the chance node is already computed, right? And then now you have the decision node. In decision node, you get the maximum. Okay, in the decision node. So earlier we have 20 and 14. Right? So in this case, you get the maximum between 20 and 14, it is 20. So then you identify the best decision is actually 20. Okay. So here, is there any question? Easy? Super easy. Hmm? You want to practice? So can you put that into Excel probably? So you can start to compute. Right? Hmm. So you can start to compute that. And put that in Excel. You better do it because this is continuation. We will have a very long of the same problem. So this is the first step. Okay, so the one in yellow here represent the one that you input. Okay. This is the, from there you can compute the expected value, isn't it? So 0.6 multiplied by 100, so you get 60. Yeah? 0.4 multiplied by minus 100, you get 20. Okay. And then you sum. This is the value in the chance node. Okay. Right? And then now for the decision node is this one, maximizing between the two. Yeah. This one EV here represent the maximum between 20 and 14. And then this is the arc max. That means you find which one among these that is the decision. Then question. Done. Okay, so next, once you have done that, okay, we can continue. Okay. So if you put this probability now becomes 0.5 and 0.5, okay, the result is 0, 0. So you cannot decide, right? This is one of the weakness of decision under risk, right? So, well, we can overcome this later on using utility. Yeah? So, okay, now let's discuss risk analysis. Okay, based on the possible payoff and the probability associated with decision alternative. Yeah, we will discuss about risk profile, value of information, and sensitivity analysis. Okay. Okay. So risk profile is basically the chart, okay, that is to show the probability distribution, okay, of the possible payoff associated with the best decision alternative, yeah, with the selected decision alternative or decision strategy. Okay, so how are we going to use that? We can compare, okay, if you have a risk profile a while ago, okay, and later on when we do certain additional decision, okay, whether we will conduct marketing study or not. Yeah, so you can start to see there is a change of probability distribution. Okay, so don't forget a risk profile represent the value of the optimum decision. Yeah, how can we get this? Okay, this one is obtained, okay, by when you select the payoff a while ago, okay, right? So big order, right? So you get this is the result, right? So high demand, you get 0.6 probability with the value of 100 and 0.4 probability with the value of negative 100. So this is the value that we plot. Okay, so 0.4 here, negative 100, 0.6 here, positive 100. Clear? So you can create your own problem, okay, payoff matrix, say put probability for each state of nature, okay, provide at least two alternative, at least two state of nature, and then you can make decision based on PLV, and can you create the, can you draw probably the decision table, decision tree, and decision table. Is that okay? You create your own, okay, and based on that, we can start to compute. Okay, practice first. I'll give you 5 minutes. Is that okay? Or you need more? No. The Okay, can you share your screen?
So get the probability, and then for this one, sorry, probability get the EV, and then summation. For the decision, for this is for only for two alternatives. What if there are three alternatives? How can I, for example, for this one, this for this one for the EV, this is I'll just get the maximum of the sum. What if there are three alternatives? How do I do it?
The same, you can get the maximum,
Same.
the sum, okay?
If for this decisions, so it
For
is
the
automatic
decision, you can use matching.
matching.
Match.
Matching.
Equal
Okay,
match,
match.
yeah.
Okay, so. Hi, sir. I'm done. I don't
Okay.
know how to do the risk profile
Uh,
review first.
the risk profile later, you can,
Okay.
now you get the big decision here, right?
Yes.
Okay, so if you can, big order decision, what make that big order decision? So based on the three diagrams, okay, you will know, the risk profile. Big order is, you look at this value that you put here. This is 0.6, 0.4, and then
Yeah.
the result is big order, right? So this one, 100 and
Oh.
minus 100. So those are the one that create the risk profile.
Wait, sir. I'll do it first.
Okay. Okay, good. So anyone else want to share screen? You can create your own problem. Okay. And if you have difficulty in anything, so you can also share it to us, and then we can discuss it together. At least can you get the result of the decision? Okay. Now, let me show you. My Excel. Okay, so these are the value that we have. The one in yellow is the one that input. Okay. So this is that we just discussed a while ago. And then this is the EV, this is the expected value. Okay, so this one is basically just multiplying between the big order and the high demand with the probability. Yeah. Same thing here. It's just the 0.4 multiplied by minus 100. Okay, and this one is the sum, right? So this is the value in its alternative. So for The EV here is just the maximum between these two. Okay. The decision you can use max or you can use just if then. Okay. So now to make the problem more complicated, you can have a sequence decision, not just one-time decision, but you can have a sequence decision. So, or what happens if you want to conduct market study or not? Okay. So, and this is the one that you know. Okay. So if you conduct market study, okay, and the market study can be correct or incorrect, right? Right. So, and then if the market study is correct, and it will say, say this is the result given. So you can, because this is in yellow, you can fill it up. Okay. So high demand will be 90%. Okay. Low demand will be 0.2. Yeah. So from there, we can compute it something else, yeah, which is actually what is called expected value of perfect information and so on. So let me show you first in the slide before this, so that you can get better understanding. So first is about the value of information. Yeah. So we have what is called perfect information and sample value of information. So perfect information means you know with certainty in advance, okay, what events will occur. So as if you have a fortune teller telling you with 100% correctness. Yeah, that is a perfect information. So the question is, how much are you willing to pay to obtain such information? Right? So the expected value of perfect information, so we call this EVPI, so expected value perfect information, is computed by subtracting the value of alternative with perfect information, so we call it I1, from the value without perfect information, call it I0. Question is, how do you compute the I1 and I0, isn't it? So EVPI, this is the symbol, delta I, and EVPI is just the change, okay? The value with perfect information and without perfect information, okay? Absolute value. Now, the question is how you will get the I0 and I1. So I0, this one, without perfect information, okay, is computed just as maximum EV. Okay, so this is just the maximum EV itself. Now, the expected value with perfect information, okay, so you compute the maximum of the gain, okay, for each row, okay, and then you multiply by the probability. Okay, so without information, you compute the gain multiplied by the probability, and then you maximize, right? This is the usual part. Okay. So basically, this is what similar to regret. Yeah. So let's compute I0 without perfect information. Okay. This one is I0. Okay. So from the first thought problem earlier, we know the decision is a big order, right? The EV is 20, right? So in that case, the I0 is actually that one, the maximum is between the 20 and 14, is 20. So we know I0 is 20, yeah? So we have decided to select pick order without information about the which state of nature will happen, right? So you have decided without any knowledge that the demand will be high or low tomorrow. So this is called expected value without perfect information. Oh, how about the expected value with perfect information? Okay. Say a fortune teller telling you that the demand will be high tomorrow. What will be your decision, right? So in this case, demand, you will maximizing between the value of 100 and minus 10, isn't it? Look at the decision tree a while ago. High demand, okay, this one, 100, and then high demand, small order is minus 10. Can you see? Now, back here, you want to maximize the value between 100 and minus 10. So in this case, you will select big order, okay, because 100 multiplied by 0.6, right? The probability is still there because you are not sure. Okay, so the question is, what is your decision if you know for sure that tomorrow the demand will be low? Again, maximizing the value between minus 150. Okay, and then you select a small order. Expected value is 50 multiplied by 0.4. Do you know how do you get the minus 10, minus 150 here? From the decision tree a while ago. Okay, can you see? Yeah, minus 150 of low demand. Okay, can you see? Okay, minus 150. Now between the two, okay, now you come back. You want to maximize the value between minus 150 and multiply by the probability, you get 50 multiplied by 0.4. So in that case, you combine these two knowledge, okay? So you will get the expected value with perfect information, yeah? So 0.6 multiplied by the maximum between 100 and minus 10 plus 0.4 multiplied by the maximum between minus 150. Yeah, so then you get 80. Okay, so knowing the I0 and I1, what you will get the expected value of perfect information, which is 80 multiplied by minus with 20 earlier, right? So in this case, you get 60. What is that 60 mean? This is the maximum you are willing to pay, WTP, okay, to get certainty of information. So remember, this is the maximum you are willing to pay for the consultant or the fortune teller or the market researcher. Okay. So if you pay the market research or the consultant less than 60, okay, that is sulit, right? So that is cheap. Okay, maximum you can pay is 60 for that information if the prediction is 100% reliable. Okay. Do you understand the meaning of EVPI?
Prof,
Okay, go.
is it comparable to the, because for consultancy we're requiring them to have a plus or minus of their, for example, demand forecast accuracy, for example 15% plus minus their expected value. Does that apply to this concept?
I think it's different. Yeah. So that probably what you said was sensitivity analysis, is it? Isn't it? Right. This is different. Okay. So later we will get the actual value of the consultant rate maximum. Okay. At this point, let's discuss about the perfect information first. If you can get 100% sure, okay, say you have a very, very excellent consultant or market research or a fortune teller. Okay. The question is, how much are you willing to pay to get that information? That is the meaning of EVPI. Okay. Later we will have EVSI. This is totally different. Okay. But at this point, I want you to understand the meaning of EVPI. EVPI means, okay, the money you are willing to pay, okay, for the consultant. So you are, most of you are maybe become consultant, right? Okay. How much is your rate? That depends on the value that you give, right, to the client. So this is a way to compute, okay, your rate as a consultant. Is this nice enough? Okay, so you can convince your client, okay, because you know the actual value of yourself. Okay, so I hope this is a good motivation for you to yeah, Katrina, you want to say something?
Prof, just a question. So is this only applicable for monetary amounts or is it also applicable for time? Because
Yeah,
how much time am I willing to spend to get perfect information?
remember EV, in the classical way, they call it EMV, expected monetary value, okay? But I deliberately changed it into EV instead of EMV, okay? Why? Because the actual value is not necessarily monetary. If you can put it into time, you can basically ordinal number here, okay? So no problem if you want to put it into time and others. Say you don't like time, you don't like monetary, or how about preference? That's also possible. Yeah, as long as it's ordinal numbers. But of course, monetary is the easiest way to understand, right? Because eventually you will go down to money. How much are they willing to pay? So in this case, monetary is actually easier. For the sake of communication. But in reality, it doesn't need to be in monetary term. Okay, good. Is there any other question or feedback? So I hope you understand the meaning of EVPI. Okay? And you know how to compute? For that fruit store problem, do you think you can compute? How much is the EVPI? Oh, maybe you try. Okay? In your exam, can you compute the EVPI? Yeah. So if you have a different problem, right? Instead of the fruit seller, so please continue also with your own decision analysis earlier to compute until the EVPI, expected value of perfect information. So how much are you willing to pay, or how much your client willing to pay, okay, for some perfect information to make the state of nature from uncertain become certain? That's the meaning of EVPI. Yeah? To make the state of nature from uncertain become certainty. Do you need time to compute or no? In Excel, can you compute that for the fruit salad at least? Please. I will show my Excel so that you can see. Can you see my Excel? So this one, okay, without perfect information, is just the maximum between these two. Yeah, 20 and 14 or earlier. Right? So, and then for the expected value with perfect information, is this is come from this probability. Yeah, and you see, this is the probability multiplied by the maximum of this value, and then this probability multiplied by the maximum of this value. Can you see that? Okay. So, and then EVPI is just minus, no? So 80 minus, and then take absolute value. Yeah? Can you do that? Can you get the EVPI? Yeah, so this is the maximum, okay, you are willing to pay in order to get perfect information that this is 100% sure and either high demand or low demand. Okay. The question, how to compute? This one is the same as earlier, so this is easy, just the maximum between the two. Now this one is just from here, yeah, from the original payoff matrix. Okay. The probability multiplied by the maximum of each column. Okay. Okay. Next, come back to okay. So of course, in reality, right? So perfect information is nearly impossible to find, okay? Unless you are having an insider trading, right? So on the other hand, the imperfect information is often available. Okay, so this is more useful than perfect information, right? So you have research, you have market study, you have consultant, you do experiment, you have model and software, yeah, to improve our imperfect information. So, well, the study can be correct, reliable, so we call it favorable, or probably incorrect, not reliable, so we call it unfavorable. Yeah? And again, this have certain probability, right? So we can assign. So in this case, we use prior conditional probability and base rule. Yeah? Conditional probability have two parts. One is called posterior and likelihood. Okay? Let me just review the term. We have the same base. Okay. So this is your payoff gain table. So A here represent the alternative. Okay. S here represent the state of nature. P here is the probability of each state of nature. Okay. So this probability of state of nature is called prior. Okay. Prior probability. That means here if I put P1 here, that means P of S1 is equal to P1. Probability of S2 equal to P2 and so on. Of course, the sum must be 1. Yeah. Okay. And then G here represent the gain payoff. Yeah? G11, G12, and so on until CNN. So M represent the number of alternatives, N represent the number of state of nature. Yeah. Next. Now, when we said likelihood, likelihood is the conditional probability that the study can either favorable or unfavorable. Favorable means correct, unfavorable means incorrect, right? So look at this. The sum of the likelihood for each state of nature is also 1. So remember, a while ago the state of nature is in the column, so now I put it in the row. Okay, now for each state of nature, okay, you have either favorable in the study or unfavorable in the study. So in that case, this is the, what is this? This is the conditional probability, which is given the state of nature is S1 and the market study is favorable. Correct. This one is given the state of nature is S1 and the market study is unfavorable, incorrect. Of course, the sum must be 1, right? Okay, and so on. See, so this conditional probability is called likelihood. Okay, next, we have also another conditional probability which is called posterior. What is that? It's the same as earlier, but we reverse. You see, here is favorable given S1. Okay, this is called likelihood. In here, this is another conditional probability. If you know this is favorable, what is the probability that this is actually from state S1? What is the probability? If this is, you know, this is unfavorable, okay, what is the probability that this is from state of nature S2 and so on? Okay, so again, the study can be favorable or unfavorable with certain probability. So posterior probability is conditional probability of the state of nature given that the study is either favorable or unfavorable. It's just the reverse. Right. So given the study is either favorable or unfavorable, what is the probability that it comes from certain state of nature? Okay. And next one, we have also the third terminology, and don't worry, this is the last terminology, okay, which is called joint probability. So joint probability is just the probability of the state of nature multiplied by the conditional probability, which is either likelihood or posterior. Okay, so if you have a probability of SK multiplied by this one, favorable given the SK, then of course the sum of all of this become favorable. And here, again, this is the, if the study is unfavorable, then this is the joint probability. Okay, that's formula. So now you can compute, okay, if you know this value on the right hand side, you can compute the left hand side. Okay. So if you know the likelihood and the priors, you can compute the posterior. So this is exactly what is called Bayes' theorem, right? So Bayes' theorem is to compute the posterior probability, this one, knowing the likelihood and the prior. Okay, with that, let's come back to our fruit store problem. Okay. This is given. Okay, so this is the given. Okay. You can input this in your Excel. Okay. This is given. What is given? Likelihood. Okay. I will put here 0.9. What's the meaning of 0.9 here? that is, the meaning is you have high demand, okay, and your market study is correct. And you have low demand and your market study is correct. Okay. This is the one that given. And the one in yellow here, and the one given. Of course, because the two of them must sum to 1, then this is just 1 minus the yellow one, right? Okay. So what is the meaning of 0.8 here? This is the probability of low demand. Given this is low demand, what is the probability that this study is incorrect? Okay, so look at this. This market study, okay, a while ago we know already 0.6 and 0.4. These are called prior probability. We know. Now, what we want to know is the posterior, right? So to compute the posterior, you need to compute the joint probability. Yeah. So first, you compute the joint probability. How do you compute that? This is given, and this is given, isn't it? This one is given. A while ago. This one 0.9, 0.2. So the top table here is given. So to compute the joint probability, you just multiply 0.6 multiplied by 0.9. 0.6 multiplied by 0.9. So this is the result. Okay. And then when you sum down here, you get probability that this is correct. And this is the probability that this is not correct. So you get the prior of correct market study or incorrect market study. Wow, this is not interesting one. So if you compute here, okay, the market study is correct is only 62%. The market study is incorrect is actually 38%. Not perfect, it's just 62% correct. Okay, the question is later we will see how are we going to use this information. Okay. So once you can compute the joint probability, okay, so now we compute the posterior. Yeah. Again, the top table here represent likelihood, so this is given. Okay. Now you want to get the posterior. Posterior mean probability of low demand. Okay, that this is actually given that this is incorrect study. Okay. So this is just you expand. Okay. This is the same as low demand multiplied by incorrect given low demand. This is 0. What is this? 0.4. Okay. Incorrect low demand is 32. This one. Yeah, this is the joint probability. Yeah. And then you can compute everything from here. And this is the result. So of course the sum in its column will be 1. Okay. So this is the posterior probability. Now this is the one that you will use. Yeah, the posterior is the one that you will use. Yes, Angelo, you want to ask something?
Sorry, Prof. Maybe I missed it a while ago. But how can we assign the probability on how correct or incorrect the assumption is?
Okay, the one that given is the likelihood. Okay. If you conduct a market study, okay, how how much is the market study will tell that this is high demand correctly? How much the market study will tell that this is low demand correctly? Is that okay? That is the one that you need to know. Say you are a consultant, right? So how much the probability that you are reliable enough? Okay, there are two alternatives, right? So say in this case, high demand or low demand. Okay, so you are the consultant. Okay, then you tell to yourself. Again, this is Bayesian probability. That means opinion. Based on opinion. So you tell, oh, if this is high demand based on your experience, this must be how much? Remember, one thing very nice about Bayesian probability is now you can set probability based on opinion, and then you can revise it. Okay, that is the nice thing about it. The previous statistic, okay, is classical. They always based on the experiments. Okay, they don't acknowledge opinion as probability. Okay? But since 1950s, okay, there are a lot of debate, and finally, now by this time, it's well accepted already that Bayes theorem is actually well established at this point. Yeah, that we can use opinion.
So,
It's-
Prof, if we add a middle, because we have high demand and low demand, if we add middle uh, average demand, what would be the
you can
probability?
so in this case you have three alternatives: or high demand, middle demand, and low demand. Then you can set some certain probability for each alternative. Yeah. Again, this is based on opinion. If your market study is correct, what is the probability? Okay. Or the other way around, if it is high demand, what will be the probability that this is correct? If this is low demand or middle demand, what is the probability that this is correct? This is something that you already know based on your opinion or based on previous experience. Okay, so based on that, you compute what is the probability that high demand, given that this is actually correct study or incorrect study. That is the posterior. I will show you again the process, and then I will show you the computation in Excel. Okay. After that, I will give you a chance to practice. I know this is very long, okay, but without practice, you will not get understanding. Okay. So this is what you see my slide. Okay. So this is the one that you know. Okay. This is the one that you know. The one in yellow. Yeah. Given that this is high demand, what is the probability that this is correct? Okay. Given that this is already know that this is low demand, what is the probability that this is correct? Or incorrect is the other way around. So this is just one minus, isn't it? So based on this, okay, you compute the joint probability. It is just multiplication of this. Okay, and then you put it down, okay? Then you get the probability that this is actually the market study is correct or incorrect. Okay, from there you can calculate the posterior. Yeah, posterior is just the other way around. So knowing the percentage by row, okay, and the joint probability, can you calculate the percentage by column a while ago? That is the posterior. Okay, so based on that, this is the posterior that you compute. Okay, of course, the sum must be 1 on each column. Okay, and then you can use that. Okay, now this is the real one. Okay, so look at this. Earlier, this is what you have. Okay, this is what you have earlier. Okay, with is no study. Then now you have two decision points here. Yeah? The first decision point, whether you take market study or not. Right? And then if you conduct market study, there are chance the market study is correct or incorrect. Okay, where is this 0.62 come from? From the table a while ago. Here. You see? Okay. So 62% and 38%. Yeah, that the probability is correct. Okay. So now, if it is correct, again the same. Yeah. This is the usual decision point. Okay. Whether this is big order or small order. Right. But if you have no study, right? So the high demand, low demand is this one. Okay, 60% and 40% and this other value. But if your study is correct, again you have a possibility of big order and low order and high demand, low demand. But now the probability is different. Now the probability is 67 and 13. Where this come from? From here. Yeah, this is from the post study. Okay, this is from the post study. 87%, 13%, 16, and 84. Okay, so there you can see. Yeah. So if the market study is correct, 87% high demand, low demand is 13%. If the market study is incorrect, high demand become 16%, low demand become 84%. Okay. Okay. So this is how we compute a while ago. From basically this is the one that you need to get. Okay. Once you get this, okay, right? So then you compute one by one. Okay. So you get the AV for its leaf node. Okay. And then what you will do, okay, for the its study, for the AV for no study we already computed. Now for the market study, you have either correct or incorrect, right? So then you compute the probability is here. Okay. And then what is the decision? The same, exactly like earlier. Just copy and paste, but change the value. Okay. And from there, you can put back, okay, what is the decision? Okay. So if no study, your result is big order. Okay. If with market study, either correct or incorrect. So these are also the result. Big order and small order. So if your market study is correct, okay, you will select big order. If your market study is incorrect, you will select small order. Okay. From there, these are what is this? This is actually the one that you will put in the risk profile. Okay, this is the one that you will put in the risk profile. Okay. So then you can compute the EV for the whole market study. Okay, which is actually you will get 61.4, right? So and yeah, 61.4 here. Okay. So finally, the result is your decision should be doing market study. Yeah. So the EV of doing market study is much bigger than no study. Right? Even though okay, the market study correctness is only 60%, 62%. But having market study is actually better than no study at all. The EV is actually higher, much, much higher. Can you see that? Okay. So, yeah. So, okay, I will give you time to do it. And then if you have any question, you can ask. So, probably I will share my screen on Excel. Can you see my Excel? Yeah. So this is the one that given. So, one in yellow, one given. Okay. This table here represent the one that we already computed a while ago without study. Okay. And these are a while ago, we already computed also the EVPI, expected value of our information. Okay. Now what we will do? We will compute the joint probability. Yeah? So joint probability is simple. Okay, this one is the one that we know, and multiply by the probability. Okay. So this is high demand and correct, right? So high demand and correct. So we multiply 0.6 and 0.9. So we get that. And then here, this is incorrect, right? This one, and then multiply by high demand, 0.6. This one is low demand and correct. So that is low demand, and then the probability is low demand here, then correct. And here, what is this? Low demand and incorrect. So this is low demand and incorrect. Multiply. Okay, so 0.8 multiplied by 0.4. So, and then you just sum. This one is just a sum of its column. Okay. Of course, the sum must be 1. Okay. Total. Okay. So I just copy here. So the probability that the study is correct is 62%. The probability that the study is incorrect is 38%. Okay. Now, based on that, we can compute the posterior. Yeah. Posterior, again, we get from joint probability. So here we have this 64 divided by 62. And then here is the second one divided by the sum of row, the sum of each column. Yeah. So that the sum here is 1. Okay. The same thing here. This is the high demand incorrect, okay, divided by the sum of the market study. And here also low demand incorrect divided by the sum of the market study. That is incorrect. So you get the posterior already. Okay. Once you get the posterior, you can start to compute. Okay, what is now you include here 87, you put it here, and then 13 here, you put it here, and just copy. Now, if the EV for incorrect, so you get from here 16, just copy. 84, you must copy here. Okay, and then this one is just simply multiplying of the probability with the actual value from the earlier, the payoff. You see that? This is the payoff matrix. Okay. Multiply by the payoff to get that value. The same thing here. This is the multiplying by the payoff with the new probability. Okay. The same thing for the this one also the payoff. D9 represent the payoff for high demand, big order. Let me show you this one. Okay. So then you can compute everything. Yeah. So this is computation for correct market study, incorrect market study. Okay. And after that you combine, right? So we have the correct and incorrect market study. So this one is just combine of this 62. Okay. And this one is from here, okay, the EV from the correct market study. And so I just copy this in here, and this is the probability earlier incorrect market study. Okay. And then the EV you can get from the earlier computation also for incorrect market study. Okay. And then we can multiply the probability with the EV, right? And then you can get the sum. The sum of these two, it is 61.4. Yeah. So this 61.4 represent the expected value with sample information I1. Okay. The earlier 20 we already computed. Okay. This one represent the expected value without sample information. So then we can just minus to compute the expected value of sample information. So this expected value of sample information represent, okay, the price of the consultant. Compare this with the perfect information, which is 60. So of course this is must be lower because the consultant is not perfect. Yeah. So we can also compute the efficiency of the study. Yeah, with this what is this? EVSI divided by the EVPI. So the efficiency of the study is actually only 16%. Yeah. From there you can compute the risk profile. You can compute the risk profile because you already know based on the decision. Okay, then you just get everything there. Yeah. Based on the matching. Match and index represent the arc marks in this case. Yeah. From there you can get the risk profile. Okay. Same thing here without study. This is the risk profile one. Yeah. So I hope this is clear enough. You need to practice. Try to make it. Okay. And if you have any question, you can ask. And don't worry to make mistake. Okay. You can always revise. So my question to you is this tools useful or not? It's useful, right? So you will know how much is your value as consultant. Correct. Or if you are government, so if you are willing to pay for consultant, you know also how much suppose you pay maximum. Okay. Yeah, we will not know the actual rate, but we know the maximum value that you need to pay. Okay. based on the assumption of the opinion in the probability. You can come. So I hope this is interesting enough. Okay. So yeah, so what is an optimal decision, right? So we know that the market study is very far from perfect. So in our example, only 62% correct. Okay, and what will be the role of that information from the market study? Okay, so we can compute, okay, what is called EVSI. Okay, EVSI is expected value of sample information. That means the actual maximum payment to the consultant, okay, because of the imperfect information that we have. Okay. The technique is the same as earlier. It's using the similar method as the perfect information. Okay. We can compute the expected value with sample information and without sample information. Okay. After that, we compute the difference in I0 and I1. So instead of EVPI, now we have EVSI. That is the actual things that you have. PI means perfect, so SI means sample. That means from the actual opinion that you have. So from there, we can compute the efficiency. Yeah. So EVSI is computed using this formula. I showed you a while ago in Excel. Okay. The technique is exactly the same like AVPI, but now you have the value whether this is favorable or not in the market study. Okay. From there, you can also compute exactly the same with this S1 minus S0. And if you divide delta S here, the AVSI divided by the EVPI, you get the efficiency. Okay. So this is the EVSI. Without study, you get 20. With study, you get 61.4 while ago. Okay, so you just minus, you get 41.4. So this is the value that you're willing to pay to your consultant in the market study. And then efficiency of study, you just divide 41.4 divided by EVPI. So you get 69%. Now, if you already know those things, okay, you can plot also the risk profile, and probably you can gain certain information based on this risk profile change. Okay, so this is the fruit store problem without market study. So we have result of big order. Okay, high demand is 0.6 and low demand is 0.4 probability, and these are the value of what is this? 100 and minus 100. So this is the one that we plot. Yeah? This is the one that we plot here. Now, when we do conduct market study, okay, when we do conduct a market study, if correct, you choose big order. If incorrect, you choose small order. So these are the value that you plot in the risk profile. So you get 100 and minus 100 at 87% and 13% respectively. And then you also have 16% of minus 10 and then 84% of 50. Right? This is 50, 84%, and so on. So now you get the new risk profile. Then you can start to compare. Now you can start to see, okay, having the market study actually spreading, okay, the distribution. Okay. So lowering this part. So instead of 4% now become smaller, much smaller here. And instead of 60% here, now become higher. Okay. So this is what is the meaning of risk profile. So you can start to see the change in the distribution. Okay. That actually marketing study produce better result than no study at all. Right. So after that, you can compute the sensitivity analysis. No? So this is to study how the change in the probability. I think this is what Angelo was asking a while ago. If there's a change in the probability in the state of nature, okay, or and change in the payoff, okay, what will be the result? The technique is the same as earlier. So you can create a table, yeah, of the probability. Okay, remember the total probability must be 1, and then you put the range of the probability, and then you compute, yeah, data table in Excel. So from in Excel you can use data table, okay, and then you can copy this high demand, okay, EV of high order and low order. And then you can set up the probability, one of them, the high demand to be 0 up to 1, yeah, with certain increment, 0.1. And then you highlight the table, and then you use data table, and then you can just push enter of the column input, then you get this table. Okay, then you plot. So from here, you know that the probability of high demand less than 0.5 will produce small order. If the probability of high demand is less than 0.5, will produce big order. And so these are the usual. So what do you think? Give me feedback so that I will know your input. Did you finish? Not finished. Okay, then I will give you an assignment for this one. Okay, so that at least you practice and you will know. Is that okay? Only open for- Now, you want to continue or you want to practice first? What do you think? Yes, so nothing.
Sir, for this practice, sir, do we have to do it until the sensitivity graph?
Yes,
Okay.
but at least
Using yes,
can
sir.
at least no, can you calculate until EVSI
EVS, sige, sir.
and
Okay, sir.
efficiency and the efficiency? No?
Copy, sir.
So can you give me feedback? What is the difficulty in here so that I will know?
For me, sir, because I was late, so I was like backtracking the formulas that we were solving that you were presenting earlier.
Okay.
So I have to read it further back.
How about the others?
Uh, Me, sir, I'm trying to apply it to my work. So, for example, the low and high demand, if we design a railway system with this much capacity
Mhm.
and with this much ridership, would the cost of construction in OMM be enough for the demand? And what are the probability that it's higher than the the capacity or lower than the capacity? So trying to appreciate the lesson by applying
That
this.
is excellent, Angela. Mm. So you start to think on how you to apply in your real problem. That is an excellent. Yes. Anyone else have input? Okay, so should I drop you or you need that time to practice? That's my question.
I think,
Should right?
I think, sir, it's I need time to practice for me, sir, because the solving or the practice needs to be like allotted more time since uh it's quite long.
Yes, yes.
Yeah, it's quite long. So because there's a lot of nodes that you have to consider, a lot of like probability, like for high demand, for the if you have to conduct a market study, and then if you will not, if the probability that it's incorrect and the correct, and so it's quite long, sir. So there's still a need of more time to probably practice
Right.
this part.
Okay. So you want to practice it now or in the house later? I mean, out of the class. That's my question. If you want to practice now, so I will not continue to the next lesson. So I will wait for you. And then you can
Sir, I only have a question for the posterior probability.
Mhm.
Can I share my screen?
Sure. Yeah.
And for this one, for the high demand, I just used what you have showed us earlier. We divided the correct high demand, divided by the sum, and I get to 0.87. But
Mm.
if I use the formula here, this one in the slide 36,
Mhm.
on this the third equation, I use the point 0.6, the probability, multiply to the correct probability in the in the joint probability times 0.54. Basically I just inputted this equation, but the answer is 1.03. How
Oh
come?
no, that is not correct in that case. So probably I
Okay.
revise. Yeah.
Okay,
So you just define. Okay.
okay, just
Once
divide.
once yes, once you get the joint probability, uh, that one you just simply divide down.
I'll divide to the sum.
Yes.
Okay.
So
Okay.
64 divided by 62.
0.62. Okay.
Right.
So this one is not correct.
I
The
think
lower part.
below is not correct.
Okay. Okay.
Probability cannot become higher than one.
Yeah, right. Okay, thank you, sir.
Yeah, thank you. Anything? Anyone else? Okay, so I can continue a little bit with the same topic, uh, so that the whole series of decision under risk can be finished today. Is that okay? Okay, so this is called minimum expected opportunity loss. Okay, so, can you see? So this is exactly the same like suffix regret. Okay, so opportunity loss is basically regret, right? So we want to get the expected opportunity loss, so we call it EOL. And we want to, because we have the probability, so now we want to get the minimum EOL. And then from here, again, we get the EVPI. Okay? So minimizing EOL, the expected of opportunity loss. Okay? This is an alternative approach to EMV. Okay? So when you use minimum EOL, you will have exactly the same decision as maximizing EMV. Okay, both are again under the topic of decision under risk, yeah, because the probability distribution is known. Okay, you remember we discussed last time during decision under uncertainty. Okay, this is the definition of regret. Regret is equal to opportunity loss. Okay, which is the absolute difference between the actual payoff GIJ here and then the maximum, yeah, of GIJ. Or if you are using cost, you can use the actual cost minus the minimum cost. Yeah? So this is just copy of last time. Okay, so now because you have the probability, okay, then you multiply that probability with the regret. You see, yeah. Okay, and then it's because this regret is cost basically. So then instead of maximizing, you minimize it. So again, you use the minimum argument of this opportunity loss. Okay? So multiplying probability with the regret, you get the loss, okay? And then you want to minimize the opportunity loss. Okay, so this is the example that we use in a decision under uncertainty. I hope you still remember. Okay. And the only difference is now we have probability information. Okay, so we have say instead of equal, so I use N1 is 80% and N2 is 15%, and then N3 is 5%. So look at this, the sum must be 1. Yeah, this is the result. From there, what you will do, you get the maximum payoff because this is gain. So the maximum of each column. Okay, so 5, 10, and 20, you get 20. Okay, 7, 5, and 3, you get 7. Then 9, 0, and negative 15, you get 9. So you get this. Okay, so this is the maximum payoff for each value of the payoff matrix. And then what you will do, you minus. Nah? So because you have the payoff and you get the maximum, what you will get regret. Remember this, 20 minus 5, so 15. So 20 minus 10, you get 10, and so on. Okay, this is already computed last time also. So because we use exactly the same number. Okay, and the only difference now we have a probability information. Okay, so this is the probability information. What you will do, you calculate the EOL, yeah, expected opportunity loss. with this, from the regret, you multiply with the probability. So 0.8 multiplied by 15 plus 0.15 multiplied by 0, and then 0.05 multiplied by 0, you get 12, and so on. So then this opportunity loss, the expected opportunity loss, you get the minimum. So this one is, the result is C. Okay. So what happened if the same number, now we change the probability? And instead of 0.8, now we change this. Okay. Then, of course, you will get a different result, because the probability changes. So if you compare minimum EOL to the suffix, the question is, will you get the same decision or not? What is actually the implicit? Did suffix minimal regret implicitly assume the equal probability distribution? Yes or no? So the answer is no. But can you try, okay, the probability distribution, and then what is the distribution result, decision result? Can you practice this so that you will know? This is easy. I think not as complicated as earlier. And you already have this value, so all you need to do is just change the probability, compute the IOL, and minimum. Is that okay? Once you finish, please share your screen. Can you also compare it, because you already have the same numbers of payoff with last time when you do suffix minimax regret, right? Can you also compare the result? Mm. Yeah. In suffix minimax regret last time, the decision was P last time, right? So using minimax regret, I will remember this slide. So the decision was alternative B. Right? So now when you put probability there, what is the decision of EO, minimum EOR? And the challenge for you is actually, can you find the probability that will result the same exactly like suffix? Anyone want to share your screen? Go ahead. Vin. Hmm. Anyone want to share screen?
Prof, I was only able to do until the minimum EOL.
Oh, and then what is the result?
The result is the 7.5 or alternative A.
Alternative A. Okay. So if you can automate that alternative A, B, C, okay, using index and matching. Or you can just use if then as well also. Okay. So then you change the probability, okay, of each state of nature. My question is, can you make it so that what kind of probability you can input there in the state of nature so that the result will be alternative P? That's the challenge. So last time, this is what we have using suffix. Right? regret is opportunity loss, so equal to absolute difference between the payoff and the maximum payoff. So we calculate the maximum payoff here, and then see the result, the value that we have, and then we get the regret, and then we computed the minimums regret. Last time we get alternative B. Yeah. This is how you get the index and match. Can you see? So that you can automatically get the result. Now, if you are using minimum AOL, okay, here, so you can set this probability, and we already know the value of regret, right? I just copy this one from L16, so this is computed last time already, based on maximum minus the gain. Okay, so maximum minus the gain. Okay, off, right? So then whatever you choose to change this probability, okay, you will never get P. So you can either get C or A, but you will never get P. So I try to make the sensitivity analysis of that table, and it will never get P. Okay, so then I just wonder why. This is interesting because apparently the minimum AOL and minimax regret of sulfates, they are totally different. Okay. The result is not the same. Let me see.
Sir, question.
Yes,
For
go on.
the mean, is it
Minimum.
okay to use only min
Yes,
in
yes.
Excel?
I mean, it's
Okay.
just minimum, yes, in Excel.
Okay.
Okay. So probably what you get difficulty is not the minimum. The minimum is just minimum, but how to get automatically the alternative, isn't it? Because you have three. How about if you have many, not just three? So in that case, you just use index, okay, and then match. I will show you. So can you see the Excel here? So the minimum is just the minimum of this A or L. Okay. Right? And the AOL is just some product of this probability and the regret. The same thing here. This is just the sum product of the regret and the probability. Okay. Then this one is just the minimum of the AOL. Now, what you want to know probably this one. Okay. So you index of this decision alternative A, B, C, and this one as 24 to 26. And then maximum max of this minimum AOL, and then with the array of EOM itself, and then you put 0 here. Using this, you can always get automatically the result. And say you change the probability here, okay, and you will get again. Say I change the probability 0.4. It will change to 8. Oh, this one. So if I put 0.4 here, this one 0.1, this is automatically 0.5, right? So that the sum is 1, so this one. Say here I change to 0.75. Oops. .75. Yeah, become C. You make it? No problem, right? So, the okay. So, interestingly, if you compare this result minimum EOL, minimum expected opportunity loss, yeah, with the Savage minimax regret, okay, you did not get the same decision. Okay, even if you use any probability distribution, you cannot get that P. Yeah. So let's say you are using, instead of setting the value, let's put it into a P1, P2, P3. Yeah. You want to get alternative P. P is the one that Savage minimal regrets something. Can you get that? What is the P1, P2, P3? So that you can get P, alternative P as the output. Yeah. So apparently is not possible. Yeah. No probability distribution of P1, P2, P3 would be able to make the minimum EOL to select alternative P. Okay, prove it. If you prove it using Excel, again, you can use data table. You cannot get, but there is possibility that maybe a small probability there that make it P, but you miss it, right? So in that case, we need to prove it automatically. Yeah, so we can prove mathematically based on the value, yeah. So AOL of A, B, and C, yeah, it is based on this value of regret. Okay, so 15, 10 to 9, these are from the regret. And to select alternative P, that means AOL of P must be less than AOL of A, and AOL of P must be less than C, right? So then we do it one by one. So if you use this algebra, then you can start to see that it is impossible. Because the probability cannot be negative. So in this case, there is no probability distribution that would make the P1, P2, P3 to choose alternative P. So what's the conclusion of that? So that means the minimum AOL is not the same at all as minimax regret. So you can use both in parallel. for your decision analysis. Okay? But, okay, having said that, if you compare this minimum AOL with the maximum EMV, yeah, with exactly the same probability, you will get exactly the same result. You can try. Okay? So minimum AOL is always produce the same decision alternative as the maximum EV. Okay? Of course, the value is not the same. Okay? Because one is EV, the other one is regret. The result is not the same, but the decision alternative will be exactly the same. Okay? And you remember the perfect information, EVPI a while ago. Okay. So EVPI, okay, you can compute it this way, right? This is the value without information, and then you compute without perfect information. Okay, for this one, you can compute, okay, which is exactly like as the maximum EMV, isn't it? So interestingly, okay, so if you compute the value with perfect information, okay, that is exactly regret, right? So that means the AVPI, okay, is exactly the same as minimum EOL. You can try. Try to practice that you can compute the EVPL, EVPI, okay, and then check that whether they are exactly the same as minimum EOL. Can you see I'm trying to connect the dots. Precision under risk, while ago. So the one that you did last week, okay, we can extend it into a time base. That is the previous last week assignment. Okay. This time we connected with the what do you call that? Expected value of perfect information, and then we connect also with expected value of sample information, and again we connected again with the AOL, expected of opportunity loss. And you can start to see that big picture now, I hope. So just remember that EVPI, the expected value of perfect information, is exactly the same as the minimum AOL, the minimum expected opportunity loss. And the decision of expected opportunity loss will be exactly the same as maximum EMV, maximum EV, as the decision under risk. If you have only one decision point that is easy, okay, you can just use table. But if you have many decision points, then you need to compute all the probabilities on each decision points. Okay. In this case, decision tree is very helpful, and together with bias or probability. Give me feedback. What did you learn today? And if you have any difficulty, you tell me. Is this too much, too little? No, but last week I remind you already. So please read before the class. I ask you, right? Because this technique is not as simple as last time. This is a little more complex. So next week, in that case, we will discuss about utility theory. This is rather simple, and then we go inside to game theory. Yeah. Please come on time. Um, I would like to play games with you in class. So this time, please to practice of this one. Can you compute the AVPI from exactly the same table?
Same. Same, sir.
The same, exactly the same, right?
60.
Yes. So APPI, okay, if you use exactly the same probability, they must be exactly the same. So this is APPI represent how much are you willing to pay, okay, for the consultant or a perfect information. Uh, in reality, what you use is not EVPI and EVSI. If you already know the probability distribution of its imperfect information. So, like the one in the study of outcome. So that one will be the assignment, so that I know that's very long, but the answer is already there in the slide. Okay, so I will just say, please compute the absolute problems. And then submit it. Once you get that, so I hope you can get better understanding on this topic. So, what do you think? This is interesting, useful or not for your study, for your project also? In many time in your life, probably you will have a sequence of decision, not just one time. Okay? And each decision depends on the next decision or the previous decision. Okay? The next decision will be depending on the previous decision and so on. So in this case, you use decision tree, and this is exactly what you will use. Okay, so I guess until there today. So thank you for today.
Thank you, Prof. Thank you, Prof. Thank you, Prof. Tulog ako.
Practice, practice.
Practice. Need some time to practice.
Thank you, Prof.
Anyone want to continue with the consultation?
Yes, Prof. Me and James, Prof.
Okay. Do you want to be recorded or no record?
I think so we're okay with any.
Okay, so I will record. Go.
Actually, sir, we call this consultation lang because we are thinking of changing the some sort of the scope and topic of our project or research. It will still be about a shuttle service program, but I think our catchment area will be different. Instead of
BGC, right?
BGC, it will be the UP Diliman campus.
Okay.
And then what we thought of is we've already found a study estimating the demand for a shuttle service program for UP Diliman. So instead of us conducting our own survey of
Okay.
the shuttle service program, we could take off from that study and expound that to a financial analysis, economic analysis, break-even analysis, etc. Mainly because I think when we were looking at the BGC study, and we were estimating the number of samples that we need to get, it was a lot, and considering our timeline, it might not be feasible for us. So considering that the study is, I think, fairly recent, it was conducted around 2021. So I think we could adjust the numbers a bit. And then we will use the results of the study for the demand analysis of our own. And then we will conduct the same methodology that we presented before,
Right.
the financial analysis, econ analysis, BEP analysis, a scenario and sensitivity analysis.
Okay.
So I think that's just our main updates
So I think no problem. Yeah.
Okay, sir. Thank you very much.
If you can use also the game theory and decision analysis
Yes, sir.
as part of your project,
Analysis.
it'd be very
Okay, sir.
nice.
Okay, sir. Thank you very much, sir. That's
Thank
just
you. Yes.
okay. Thank you very much, sir. That's it for us.
Yes.
James, do you want to
James,
add
do you have
anything?
any?
Ano po nun? Sino po? Ano po?